Hello, everyone. Mr. John here from Air Team Institute with this week's Thursday Tidbit, where we're going to be talking about picking a perfect NCAA tournament bracket. Now, inspiration is, of course, the college basketball tournament referred to as March Madness every spring, every March, and it's happening right now. So it started last weekend with the first couple of rounds, and we're going to be continuing the next couple of weekends as well. In general, this is a 64 team, more on that in a second, competing in a single elimination tournament. So this is where we have the different rounds, right? So everyone plays a game, half the teams are eliminated. So you'll notice, and we'll come back to this later with some calculations, 64 is a multiple of 2. That's not by accident. So they compete in this single elimination tournament to crown the champion. Now, tens of millions of people compete every year in what are called bracket challenges, and they want to predict outcomes, try to win prizes. Basically, they want to predict who will win the game, who will win the next game, etc., etc. Now, looking at the bracket here a little bit, right? First things first, if you don't know much about the tournament, this is not super important, but just for completeness, there is this so-called first four in the NCAA tournament. We are going to be ignoring that. So that's a couple extra teams. So officially it's 68 teams, but then it quickly reduces to the 64 team bracket. So when we say the word bracket, we're talking about this whole chart here. This is the updated chart so far for this tournament. So a couple of the first rounds are filled in. Of course, when we're talking about the predictions and the chances of that, we can ignore that and just do it in general. But this gives you a rough picture of what's happening in this bracket. So we start with the 64 teams. They're seeded. That will come into play more later as well. And then they move on in the tournament until there's only one champion at the end. So just very, very rough ideas here. What would it take to pick a perfect bracket, right? And this is take one, meaning this is going to be our rough calculation, and we're going to explore ways and challenge you to find ways to improve on this as we move on in this video and for next week's continuation. So, right, assuming each game is a coin flip, right? What do we mean by that? Well, either in your prediction or the outcome of the game, anytime one of these games is played, suppose you have a 50-50 chance of getting that estimate correct. So what we're really saying here when we have this is a coin flip. We're assuming that the probability that you can estimate a single game, right? So the probability for one game that you guess is going to be equal to 1/2 in this case, right? So this is a single game in that case. So you're guessing a single game, and our assumption for this coin flip calculation is that that probability is going to be 1/2 in this case. Now, right, that part is simple. And our main question is, well, how many games are there going to be, right? So our question then we need to look at is, well, what is the total number of games that we need to predict in this scenario? So you could go back to the graph and count this. There are other tricks of this, but just getting us into the framework, right? We might not be used to thinking in terms of these brackets and stuff there. So let's look at that in this case, right? So we start with 64 teams in that scenario. And in round one, right? So we're going to have these different number of rounds. And every round, all the remaining teams play one other team. So in this round one, right, there will be 32 games because we have 64 teams, so there are 32 games in that case. And of course, that means we have 64 teams, 32 winners, 32 losers. So we reduce this to 32 teams after a single round. Now, I'm not going to write out all of this in as much detail, but then we eliminate another 16 teams, get down to 16 teams left. Then we go down to 8, 4, 2, and 1 from there. So making sure we don't run out of room here. And so for counting the games, we have 32 games, 16 games, then we have 8 games, then we have 4 games, then we have 2 games, and then we have 1 game. So if I highlight all of our games that we're counting up along the way, right? So we start with our 32 games at the beginning, and then as I was mentioning, 16, 8, 4, 2, and 1. And this gives us in total, we are going to have 63 games. Now there's some fun ways to think about this, right? It's good to practice with the brackets. It's good to add them all up that way. Notice that this answer makes sense as well because we started with 64 teams. We want to get down to one single champion. So that means we need 63 games to eliminate all of the other teams in that case. So what does this tell us about our perfect bracket then, right? What is the probability of this perfect bracket there? Well, we said we have a coin flip, so there's a 1/2 chance for any game we have there. So 1/2 chance for every individual game, but this needs to happen 63 times, right? So the calculation for this perfect bracket is pretty easy. It gets much more complicated if we're talking about almost perfect because it depends where your guess is wrong. Because if you guess the wrong team at the beginning, then they're eliminated the rest of the times in that bracket. Remember, when you're typically picking a bracket like this, you have to do it all at the beginning. You don't get to re-choose the second round, third round after the first round happens. So you have to make all of your picks. So if you have a pick that's wrong in the first round, it's going to continue to be wrong if you chose them to move on further and further. Now, this number is astronomically small. So this is roughly 1.08 times 10 to the negative 19th power. So this is less than a 1 in 9 quintillion, right? You might not have even heard that number. That is so big, right? We're used to even billions, trillions being so big. Quintillion is a few steps after trillion even. So this is a 1 in 9 quintillion roughly chance, less than that if we're talking about a perfect bracket. Now, like I said, we've had tens of millions of people each year do these brackets. As far as I know, there's not been a perfect bracket in recent years, probably never in that case as well. So these things are very, very rare in this case. Now, I did say take 1. So moving on to how we might improve this estimate. This estimate is probably low. And let's look at a single region. And this is what we're going to focus on the rest of today and in the video next week as well, just so we have 16 teams rather than the full 64. And this does make sense in terms of the picture for the actual tournament. They're divided into 4 regions, and each of those tournaments can be thought of as a 16-team tournament. Then this reduces the 64 teams to 4. They have the final 4, and that's the last portion of this tournament. But we have these 16 teams there. And I want to draw our attention, and this is where we might hope that the odds are better than our 1.08 times 10 to the negative 19th power. And that is these seeds that are coming up on the left side here. So each region has these 16 teams. There's 16 teams in this tournament, right? They're seeded 1 through 16. 16 is the worst, 1 is the best. And then they play in this way. So it's not necessarily a coin flip because, for example, a 16 seed has only beaten a 1 seed one single time in the whole history of the men's NCAA basketball tournament. So this happens each year. There's 4 number 1 seeds, 1 for each of these regions. Taking all of that into account, this number 1 seed has only lost once in the history to that 16 seeded team. So in fact, we might be able to use these seeds to make better estimates there. And that's what I want to challenge you to do before next week's video, and we will discuss that a little bit more next time. So, questions we might want to consider, right? We want to estimate and do a better estimate than this coin flip for a perfect region. So this is going to use the seeds. So try to do some research or an educated guess based on what I've told you already for estimating how likely it is for an X seed to beat a Y seed. I already told you that pretty much a 1 seed always beats a 16 seed. That's not, of course, fully true, but for practical or estimation purposes, we could maybe assume that. And then use those estimates to try to come up with the probability of picking a perfect bracket for one of these single regions. Not the full 64 teams, but as a challenge, you could look at that. And compare this to the probability if a coin flip, right, 50-50 is used. Is this improving our estimate? Well, it should. By how much have we kind of had a larger estimate or things like that to keep in mind? That can be helpful as well. Okay, so some hints in this case. So first of all, we didn't really talk much about how our actual estimate or how our actual kind of prediction is going to work. But with the seeds especially, it should be pretty clear that you want to base these things on the higher seed going on. Does this ever happen fully like this? Well, that in itself is not very likely, but that's kind of what our question is equivalent to. So you're basically kind of saying, let's come up with some estimates for how likely it is for the 1 seed to beat the 16 seed, 8 to beat the 9, etc. And then that would kind of fill in our bracket with the higher seed always winning. And we're pretty much trying to calculate the probability or estimate the probability of this happening there. Now, some starting points to come and work from, right? So we already said that 1 beats 16, you can think of as, right, maybe just for estimation purposes, this is roughly 100% of the time. If you say, well, we shouldn't use 100%, maybe let's use 99%, that's fine as well. But maybe you can start with some assumption like that, right? Maybe if you want to do actual numbers and stuff for research, that's great. But a good way to, if you want to just do this mathematically or intuitively, right? Maybe, okay, 8 beating 9 is a coin flip. So when these seeds are really close together, maybe we assume that's a coin flip. When they're far away, like 1 in 16, maybe say that's roughly 100% chance. And you could do some estimation and interpolation from here to come up with ways to estimate how these other seeds beating those other seeds might work from there. Try to keep track of those assumptions and ways you think of that as well. Now, that will do it for this week's video. Stay tuned for the continuation next week. You can, of course, watch some of the basketball games this weekend if you want to follow along there as well. Otherwise, I will see you next time. Let us know in the comments if you have any suggestions for future topics or you want to share some of your ideas before next week's video. That would be great. If you like this video, please like and subscribe for more of these in the future. Otherwise, I'll see everyone next time. Goodbye.